All right, up next is multiplying polynomials. So we're actually going to break this into two smaller Edpuzzle video lessons. So we're going to start by just looking at how to multiply a monomial by some other polynomial, whether it's a monomial, a binomial, a trinomial, or just a polynomial. But we're going to take a single term and multiply it by some type of polynomial. That's going to be this first lesson. And then the second lesson will be when we multiply like a binomial times a binomial or a trinomial times a trinomial. And we'll look at a strategy that will work for any polynomial multiplication. So first thing we have to do is just to review from our exponents unit that when we want to multiply two monomials together like this, 3x squared is a monomial times 5x squared, which is another monomial. It's really just a matter of multiplying like terms, or like parts, I should say. So we can regroup, since it's just multiplication, I regroup the coefficients first. 3 times 5 is 15. And then when I multiply the x squared times the x to the 6th power, just remember that you're not actually multiplying the 2 and the 6 together, because those represent how many of the x's are being multiplied. The rule that we used for exponents told us that we should add the exponents to determine how many total x's are being multiplied together. So it should be 15x to the 8th power on something like this. So we multiply coefficients, but then we add the exponents within that on that variable. All right, so that's how we multiply monomials together. So let's take a look at a few examples. For example A, we're multiplying 7m squared times negative 3m to the 4th power. So first thing I want to just show you is it is multiplication like this. That, yes, it looks like a monomial times another monomial, but really it's like multiplying four things. We've got the 7, the m squared, the negative 3, and m to the 4th power. So when I regroup, kind of rearrange everything that I'm multiplying, I can multiply the coefficients together. I get negative 21. And then just remember, when I multiply the m's together, I'm not saying to multiply the exponents together. It's just m times m times m times m. You're just trying to figure out how many m's are being multiplied together there. So we will add the exponents, as our product rule would tell us to do. So negative 21 times m to the 6th power, for example A. I definitely encourage you to pause the video. Try example B on your own. When you're ready, click continue and see how you did. So one way we can do this is just literally break everything into parts. You've got the coefficients are separate factors. You've got each variable as its own factor, and we're just going to regroup. So we have the negative 5 times the 8. That's your coefficients. Then we've got our different powers of c. So c squared times c to the 4th power. And then we just have the d squared at the end. So multiply your coefficients together to get negative 40. And remember that when you multiply c's times c's, you add the exponents. So that's going to be d to the 6th power, or excuse me, c to the 6th power. And then we bring down the d squared. There weren't any other powers of d, so we don't combine that with anything. Just leave it like that. All right, so that's how we multiply monomials times other monomials. And that's going to be important because as we move forward and multiply bigger polynomials, we end up basically multiplying two monomials together every step of the way. So here we're going to use the distributive property to show how we can multiply a monomial by a binomial or just any polynomial. And this really is a lot like how we distribute. It's the same thing. We're going to start by multiplying 3x times 6x in this problem, which you could write as 3x times 6x. But then we also want to take the 3x and multiply it by negative 8. So positive 3x times negative 8. When we multiply those items together, remember how we multiplied on the last few examples? We multiply the coefficients, so 3 times 6 is 18. And then when you multiply the x's, just count up how many x's are multiplied together. X times x is x squared. My second multiplication, I'm multiplying a positive times a negative, so I'm actually going to just use a minus sign there because I know the result is a negative term. And 3x times 8 is like 3 times x times 8. I know it says negative in the parentheses, but I already counted that with the subtraction. So now it's really just 3 times 8 times x, which is 24x. Since my two terms have different variable parts, that's my final answer. I can't combine any terms because they're not like terms. So 18x squared minus 24x is my answer for number 1. Let's look at this one. This time we get a few more exponents involved, but we're going to do it the same way. We're going to start by multiplying. So 4x cubed times 3x squared. And then we're going to multiply, let's see, positive 4x cubed times negative 8x. Multiply the first two together by multiplying the coefficients. 4 times 3 is 12. And remember, when you multiply the powers together, you're actually adding the exponents. X to the third power times x squared is x to the fifth power, since 3 plus 2 is 5. In the next part, I'm multiplying a positive times a negative, so I know that's going to be a negative answer. 4 times 8 is 32, and x to the third power times x to the first power is x to the fourth power. Remember, you're adding the exponents. 3 plus 1 is 4. So I have something x to the fifth and something x to the fourth. Those are not like terms. So that is my final answer. I just make sure I write it in standard form. The term with the largest exponent should go at the beginning, and then it decreases based on the exponents. All right, number 3. This time we're multiplying a monomial at the beginning, so negative x cubed, by a trinomial. Notice there are 1, 2, 3 parts inside the parentheses, 3 terms. So when we distribute, we actually have to distribute 3 times. So we're going to take negative x cubed, which I'm going to write as negative 1x cubed, times 5x squared. Then we're also going to take negative x cubed times 4x. And finally, we need to take negative x cubed times negative 11. So we have 3 multiplications to do. Remember that within each multiplication, you want to figure out, is it positive or negative? Then multiply the coefficients together, and then finally add the exponents on the variables. So in the first one in red, I am taking a negative times a positive, so that's going to be a negative. 1 times 5 is 5. And when I multiply x cubed times x squared, I add the exponents to get x to the fifth power. In my middle term, I'm multiplying a negative times a positive, so that again will give me a negative product. 1 times 4 is 4. And when I multiply my powers of x, I add the exponents, 3 plus 1. So that's going to give me x to the fourth power, negative 4, x to the fourth power. And finally, the last multiplication in blue, I'm multiplying a negative times a negative. This time that will give me a positive. 1 times 11 is 11. And I have x to the third power in one part of my multiplication, but not in the other. So it's just x to the third power brought down. So there it is. I have no terms that are alike. They are all different exponents on the variable of x. So I can't combine them any further. Negative 5x to the fifth power minus 4x to the fourth power plus 11x to the third power.